Okay, Assalamu alaikum. The topic that we'll be doing today is trigonometry. Now, what is trigonometry and what is it used for? Before we go on to that, let's first understand the very basic things, very basic rule of a right angle triangle that we had studied earlier. This is a right angle triangle. So the side that is opposite to the 90-degree side is called the hypotenuse. The one which you feel is on the floor, you call that base, and the one you feel is perpendicular to the base, you call that perpendicular. So the three sides of a right angle triangle. Okay, class. So once you have a right angle triangle in which the three sides are your main concern, how do you link it? You will say that h square is equal to e square plus e square. So if you're concerned with the sides of a right angle triangle, you can simply use the Pythagoras theorem, which is the square of the hypotenuse is the sum of the square of perpendicular and base. And while using the Pythagoras theorem, you don't need to worry about which one is the base and which one is the perpendicular, because they are both being squared and eventually being added. So that's something that you don't need to worry about. All you need to be sure about is the side that is the longest side, which is opposite to the 90-degree. The longest side is called the hypotenuse. Is this clear? Anything that is not clear till now? Okay, moving on. Now, okay, now we are talking about trigonometry. What is trigonometry? This is the first topic when you'll be linking two different worlds. What two different worlds? One is the world of angles. We recently concluded that topic. Did we use sides as in any of the calculations that we did for angles? No. There was an entire different calculation which were specifically concerned with angles. Angles in polygons, angles between parallel lines, angles at a point, right? So we were specifically concerned with angles and we did not care about the length or the dimensions of the sides. Did we? No, we did not. Similarly, there is a world of sides, a world of dimensions, a world of lengths. And recently we did the Pythagoras theorem. We can clearly say that angles were not involved in that, right? Now, trigonometry is the bridge which connects angles and sides. When you study trigonometry, you would be relating to functions, relating to calculations which would involve both the angles and the lengths. So we need to make the connection between these quantities right from the starting. How do we do that? Let me call one of the angles as theta, right? Now, how do we label sides? Okay, hypotenuse is a short side, the side that is opposite to the 90-degree angle, and the longest side. Now, the two sides that we name it in reference to the angle. And these are very simple English words. What do you understand by the word opposite? When you say that the house opposite to mine, what do you mean? Very good. The house that is in front of your house, right? Similarly, we are relating the side to the angle that we are using. So if this is the angle theta, I'll call this side opposite. Right? And what do you mean by adjacent? When you say that my friend is sitting adjacent to me, what does that mean? Beside, right behind you, right? Not behind, beside you, sorry. So what do you say? The side that is right next to the angle is called the adjacent. Don't get confused with the hypotenuse. Hypotenuse is also next to the angle, but that is the side that we have already decided for. Is this clear? Okay, now we have named the sides in reference to the angle that we are using. Now, there are three trigonometric relationships that we'll study. One is sine. Sine is a function. You don't need to worry about it. Calculator will do these operations for you. You don't need to worry about calculating it. You just need to know how to use it in a function. The moment I press sine, the program gives me with a block. What does it want? The input is our angle, which is theta in this case. Once I input the value, the calculator will provide me with an output. It will give me a value. And that value will always be equal to the ratio of opposite upon hypotenuse for a sine theta. Is this clear? Remember, all of these concepts are only limited to right angled triangles. If it is not a right angle triangle, we cannot apply these basic relationships. So sine theta is opposite upon hypotenuse. Theta is the angle that we plug in. And the answer, the value that we get is the ratio of two sides of a right angled triangle. Right? Okay, let's call this one SOH. Sine is opposite upon hypotenuse. This will help us to bring it on our fingertips. Sine is opposite upon hypotenuse. Similarly, cos of theta is adjacent upon hypotenuse. Again, theta is the angle we plug in. Calculator provides us with a value. And that value is always equal to the ratio of the two sides. In this case, the two sides are adjacent and hypotenuse. We call this CAH, so Ka. And then we have tangent theta, which is equals to opposite upon adjacent. And we call this Ta. So what helps us understanding the entire thing? We say so Ka. This is just something that will help us to bring this entire thing on our fingertips. Is this clear? Anything that you people are unable to understand till this point? Remember, when do we use it? With only right angle triangles. And remember, the angle, never take 90 degree as the angle. 90 degree and hypotenuse are something very obvious for a right angle triangle. The remaining calculations involved for the remaining two angles and the remaining two sides. So whenever you're using one of these trigonometric relationships or the trigonometric ratio or the trigonometric function, you are concerned with three quantities. One is the angle and the other are two sides. That's right. So whenever you're using this, be sure that one of them is the unknowns and the remaining two are the known quantities. If you want to find out the angle, you must know the two quantities that you are using. If you want to find out one of the sides, you must know one of the angle and one other side. And all of these are very limited to right angle triangle. Is this clear till this point? Now let's try to attempt a few questions, a few examples for these questions. Okay, now the question wants us to find the angles. How do we do that? First, we need to understand if you want to find out the angle in a right angle triangle, and we have a couple of sides. How do we do that? How do we do the first one? Okay, again, if the angle is provided, I have the angle in with me. So what two sides are provided? One of them is the, again, give it the reference of the angle, opposite and adjacent, right? Opposite and adjacent. So what do you apply when you have opposite and adjacent? O and A, tan. Okay. Remember, there is an easier trick to do this entire thing. I'll get to that once you understand this thing. So tan B is 2 upon 2, right? Then what? You need to figure out B. So you will say that is tan inverse of 2 upon 2 is 1. And then you just use your calculator. You say shift tan inverse of 1. Tan, and right above tan is tan inverse, and then you get your value 45. Was there an easier way to do this entire thing? A very easy way could have been adopted to solve this question if you would have used your observations. It's a right angle triangle and it's an isosceles right angle triangle. You do not even need trigonometry in this part. So that is what I always say. Whenever you learn a new topic, do not forget the previous one. It's an isosceles right angle triangle. If this angle is B, can you tell me the other angle? It will also be B. So B plus P plus 90 is 180. You do not even need to use trigonometry in this. Please be vigilant about this. If you can do something easily, if it's a question in paper one where your calculators are not allowed, then don't just force yourself to go for trigonometry. Okay, in the next one, again, next one you inevitably have to use trigonometry. What do you do here? Again, trigonometry. Look at the angle. See, a very easy thought. Is the hypotenuse provided? No. Do you have to find the hypotenuse? No. Hypotenuse is not of your concern. You either go for, you'll eventually go for tan. Is this right? Okay, so tan C is opposite is very good. See now this reference makes things easier for you. It avoids confusion and it will help you get the right answer. Tan inverse of 2. So use your calculators and tell me the angle that you get once you do tan inverse of 2. Three point 43. So let's write it as 63.4. Angles in degrees can be rounded off to 1 decimal place as the final answer, not for the working, but for the final answer, they can be rounded off to 1 decimal place. Other values have to be rounded off correct to 3 significant figures. Okay, what about this? How do we do part C? First, have a look at the sides of, you need to figure out the angle, right? Which two sides do you have? You have the hypotenuse. So you're not going for tan, right? Now you need to decide sine or cos. Opposite as well. The side that is right in front of the angle that we are concerned with. Opposite and hypotenuse. Sine. Very good. Sine x, the opposite is 10 over 12. And you simplify 10 over 12. Even if you don't do it, nothing to worry about. Sine inverse of, you can write it as 10 over 12 or 5 over 6. I'm writing it as 10 over 12 to avoid confusion. You can also write it as 5 over 6. It's the same thing. So what is the value of x? Expect everyone to use their calculators and give me with the right answer. Yes? 4 degrees. Okay, what about this one? Hypotenuse you have again, sine again. So sine x is 11 over 14. X is sine inverse of 11 over 14. What is the value of x? Sine inverse of 11 over 14. Make sure which error is your calculator giving, syntax error or math error? Math error means you must have put 14 over 11. Only then 51 point. Is this clear? Okay, what about this one? Very good. We'll use cos x. What is the adjacent? 9 over 12. Again, this can be simplified to 3 over 4. But if you don't want to do it and you are adamant on using the calculator, that's perfectly fine as well. So what is the value of x? Okay, what about this one? Cos again. Cos x is 3 over 8 and x is cos inverse of 3 over 8. What is the value of x? Yes, better. 67 point. What do you have after 9? So you cannot write it as 67.9. I'll show you, see. Once you do this, cos inverse of 3 over 8, 67.97. And now you want to write it correct to one significant figure, one decimal place, sorry. So you want to round off this 9 because it has a 7 after it. So you round it off to 0 and that makes it 68. So you write it as 68.0. And this 0.0 shows that you have rounded it off. It is not exactly 68. You had to do it for the sake of rounding it off. Is this clear? Okay, what about this one? Look at the two angles. This is an angle, sorry, the two sides. You have an angle and this is a side that you need, which is opposite. Again, do you have the hypotenuse or do you even need to find the hypotenuse? No, so tan is out of the equation, right? What to remain? Sine and cos. Sorry, hypotenuse is not in your focus, so tan is the only option you are left with. Sorry. So tan is the only option you are left with. Hypotenuse is neither a known quantity, nor is it something that you need to find. When you're not concerned with hypotenuse at all, you go for tan. So you write it as tan 43. Opposite is y, adjacent is 9. I'll tell you when to use the calculator. Do not rush in using the calculator. 9 is being divided on the right side. If you bring it here, you can write it as 9 tan 43. It is understood tan 43 as a value, and that value will eventually multiply by 9. If you put this entire thing in your calculator as it is, will provide you with the answer 9 tan 43, which is 8.39. So do not insist on using the calculator early on just to find the value of tan 43. Let tan 43 be tan 43. Is this clear? And then you multiply it with 9. And if you have written it like this, see, I've even written it in the calculator like this. And the calculator knows that the value of tan 43 is being multiplied by 9. Like write 9x, you know that 9 and x are being multiplied, right? Similarly, when you write the values in this form, the calculator knows it. So save yourself some time, make it easier for yourself. And what is the final value? Remember, now this is not an angle. I don't have to write it to one decimal place. I have to write it to 3 significant figures. 8 is the first significant figure. 3 is the second. 9 is the third. What do I have after 9? 2. So 9 remains as 9. And this is 8.39 centimeters. Is this clear? What about the next one? Hypotenuse is there, so no chance of tan, right? I only need to understand sine or cos. Look at the angle. Which side are you concerned with regarding the angle? One of them is the hypotenuse. The other one is opposite. All you need to know is opposite किसमें आता है? Sine, simple. Sine 70. Opposite is y over hypotenuse is 16.6. So 16.6 is being divided over here. I'll bring it here and I'll write it like this. So now what is the value of y? Is this clear, bachon? So 15.5 is the third significant figure, right? 1, 5, and then 0.5. So 0.6 centimeters. Is this right? So angles you need to round off correct to one decimal place, and all the other quantities you have to round off to 3 significant figures, the final answer, until unless it is specified. Okay, class. Let's do a couple more questions. Hypotenuse is there, so no chance of tan, right? It's an unknown. Take your time and then decide which trigonometric ratio would you want to use. I told you so ka toa is an easier way to get it on your fingertips. So ka toa. So look at the angle. One of them is the hypotenuse. Now the other one is opposite to the angle. Opposite. Where do you see opposite? Sine. Sine is opposite upon hypotenuse. So ka toa. That will make it easier for you to get it on your fingertips. And trust me, once you start practicing it enough, you will eventually get it on your fingertips. So I'll say sine of 36.2 is opposite is 21 over hypotenuse is y. Now stay with me. Do not rush in using the calculator. Y multiplies with sine 36.2. Remember, sine 36.2 has a value. Now what do? I need to find y. 21 divided by sine 36.2. Now this makes it easier for you. You just need to use the calculator once. You don't need to write the big decimal values. You don't need to round it off in the middle stages. Now you can just use your calculator, put the entire thing in your calculator and let it do the work for you. But you need to know that sine 36.2 is a value. All of this is single value. What answer do you get? What do you have after 5? So, yes. Is this clear? Now, what about this? Do you have the hypotenuse? Do you need to find the hypotenuse? You're only left with one thing. Tan. Tan 28 is equal to, yes. What will it be equal to? Toa. Opposite upon hypotenuse. Opposite upon, adjacent. Opposite upon adjacent. Now what? Anything that is not clear till this point? Is this clear? Yeah. Let's do a couple of more questions. Yes, class. Cos, okay. Cos x is adjacent 10 upon 15. So x is cos inverse of 10 upon 15. What is the value of x that you get? 48.18. I'll have to write it as 2, right? Remember, I'm trusting you with the values. I'm not figuring out every value on my own. To be sure of the value that you quote. What about this? Cos again. Cos x is adjacent 3.4 upon hypotenuse. So x is cos inverse of remember the limitations that I've just told you. $49 point. 49.2. Is this clear? Let's just do 2 more questions, 2 more parts in which we'll try to figure out all the remaining sides and angles. Okay, now what do we need to do? Nearest centimeter or degrees. This is a very basic question. All unknown angles and lengths of each triangle. So, okay, so first let's find the third length because that is something that is easier to do. I have the side 8 and I have the side 4. Now, one error that you people normally make is you name every unknown as x, 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 x. Avoid doing that. Like in this question, there are many unknowns. So for your own sake, avoid doing that. If an unknown has a name, try to give it that name. And this will be required when we go further to trigonometry. Okay, now first let's find the length. Which length do we not have of this right angle triangle AC? Right? We have the remaining two lengths and we want to figure out the third length. What should we do? Pythagoras theorem, we don't need trigonometry. Okay, Pythagoras theorem is h square is equals to p square plus p square. So h is AC. I'm writing it as AC square is 8 square plus 4 square. Can you just square 8 and 4, 64, 68? That is 68. Then you take square root on both sides and this is your value. Now the question says to write it correct to the nearest centimeter. So now you can round it off, but I'd advise you that when you, if you want to use this value for your future calculations, use this value under root 68, which is called the exact value. If you want to use this value for your future calculations, use under root 68 as it is. But the question says to round it off. Yes, class. What is the length that we get under root 68? You have to use your calculator. You cannot just tell me the answer. Under root 68 is 8. Question said to round it off. This is 8.24. I can just write it as 8. Nearest centimeter or degrees, 8 centimeter. Again, this is a very big rounding off. We do not do it, but the question says so. That is the only reason we are doing it. Is this clear? This is 8.24. But I cannot just write this down. 8.25. Let me write it as 8.25. Okay, now I need to find the two angles. Which two angles do I need to find? Angle A and angle C. Let's decide one at a time. And try to use the values that are already provided in the question rather than the values that you have calculated. So, how do you find the angle A? Yes, so we can use SOHCAHTOA. It is a right angle triangle. I want to find the angle A. What two sides do I already have? I know the third side as well now, but what do I already have? Yes, so I don't have the hypotenuse, easier one. What do I do? Yes, I had bit.
Sir, for 8 square plus 4 square, isn't it 80, not 64?
Okay.
Sorry, 68.
I don't know. I'm telling you the values are being quoted by you people. What is 8 square plus 4 square? Thank you, I had better for the correction. I told you I'm trusting you people with the values. So what is under root of 80? Thank you, I had better, well done.
8.9.
So I can write it as approximately 9. Is this clear? Thank you, Ad. Okay, now what about A? How do we find angle A?
10.
Tan. Let's apply tan at A. I'll say tan of A. Call this angle A because it is being formed at point A. Tan A opposite is 4 and adjacent is 8. So A is tan inverse of half or 4 upon 8. Same thing. What is the value of A that you get?
Five.
26.56 or 26. Now what other angle do we have? C. So I can say that 26.5. Sorry, thank you. 27. 26.5 plus 90, I'll just write it as 27 because the question says so, but I'm repeating it. Do not do it in the exams. This question wants us to round off all the values correct to the nearest centimeter or degrees because it just wants us to focus on the method rather than the answer. But once you encounter the same thing in exams, angle have to be rounded off to 1 decimal place and all the other quantities have to be rounded off to 3 significant figures until and unless specified. So 27 plus 90 plus C is 180. Can you find the third angle? Or you could have used trigonometry to get the third angle as well. But if you know two angles of a triangle, can you get the third one this way? 60. Even if you would have used trigonometry, you would have still landed on the same answer. Is this clear, bachon?